Okay, good evening. So already since morning we have some interaction with Dr. Panda. So he has talked about his experience and again will continue for next 4 days. Here only to add to it, I am adding some of the different types of tailings and how it is you can characterize, because obviously field investigation is the best, later on we will again discuss, but also we need to know how it is varying. So this is because long before in 1991, when I started my MTech, my professor recently expired only. So he gave me some flyers and said you characterize it. I mean nothing else. So he left to Bangkok. So for 2-3 months I was just trying to learn what is this material. Because that time you think about 35 years, it was nothing, I mean no idea about this fly ash also. So this is already, if you see there are two types, morning also Dr. Panda has shown it. So you can have both, like waste rock, like our coal mine overburden is a waste rock. And also in iron ore also some waste rock. And then also comes iron ore tailing. So actually that time everybody was saying that it is a waste, but I said it's not waste because it depends upon how much knowledge we have got. If you have got full knowledge, it becomes a wealth. Partial knowledge becomes a byproduct. When you get no knowledge or limited knowledge, we call it as a waste. Because you don't have knowledge in fact. That's why we are saying it as a waste. Nothing is called waste. So this is how we dispose. In Indian context, I have got some photographs here, like we have got say coal mine overburden nearby thermal power plant, and there is also coal bauxite residue. This way we dump it. The problem is geo-environment. Like where is geo-environment? That means what we are saying, air, water, soil, and also the human should not be affected by this. So what is affecting? Mostly we are saying heavy metals. But that is again maramari for heavy metals. Because heavy metal is the critical minerals and that is the most sorted after. So if you can identify those heavy metals, take it out, then you utilize it, or we store it also somewhere, it will not be effective. Because long before in 2021 or so, once there is a fly ash, they are dumped it failed. What happened? It went to the agricultural field. Then we visited just to say that how to protect it. So he obviously claimed that my agricultural land is lost. So that way, this is fly ash. Now forget to the other one. So obviously, there is what we need to know, that how to characterize this. So then geotechnical engineering, I call it the geomaterial. But if you read as a 3-phase system, but if you read it is nothing but I call it particulate media. Like you might have heard about aerosol. Aerosol is also particulate media. But air is more and water and solid particles are less. But in this case soil, my solid is more and then water, then air. Just opposite. So that's why that is also particulate media, this is also particulate media. Because when I want to learn it, just I want to give a touch that from physics how we will go for this geotechnical engineering. So that way its as a whole properties will depend upon the individual properties. Then what is the target? Because when we have done geotechnical engineering, it was easy. We have developed in the last 100 years, almost 1919 or 20, almost 100 years. So the problem is, if you see, this macro scale properties will depend upon this interaction of the particles. First is chemical composition. We have never got taught in soil mechanics what is the chemical composition. Only the other 3 minerals, monazite, kaolin and illite. Nothing more than that. But when it comes to tailing, I need to know chemical analysis. Then geometry. Soil, we have read sands are subangular, angular and so on. And clay are plate-like structure, whether it is monazite, clay, light and so on. But here, if you look at this one, I have shown you different wastes only. All these 3 years. Somewhere is very irregular. Somewhere it will go to fly ash, I will say totally spherical. So these particles are also different. The geometry is different. Volumetric or gravimetric. That's what also Dr. Panda will show it with that dry stacking. I asked some also immediately, what is the weight of water when you go for tailing, what is that? So he said, suppose say 30%. 30% by what? Weight or volume. Because what is the problem? Soil, we are estimating the specific gravity only 2.65. But if you go to aerotic, the specific gravity 3.2. So even if you also 10% moisture content, the volume wise will be more. Which will affect it, which you will not able to identify if you will consider as a pure geotechnical engineering. Because that I know. Because moisture content, OMC is 13%, plastic limit, liquid limit, then it will be like this. So I can find out the properties. But in this case, that water content is not sufficient also to know about volumetric. So we have got both volumetric and gravimetric. We should know volume by volume. So that will make a difference. Then comes mechanical properties. Some of these industrial also, whether it is crossed or not, that I will show with the particle size. Once you compact the once you compact also, some of the particles may crust. Then last two properties, yet you have to consider. That is called thermal properties and electromagnetic properties. Now only research stage we are trying to get it to identify what are the good minerals. Sorry, it might have got disconnected.
Progress.
Okay. So now I am talking about simply a chemical composition. I have got different types of some those who are from steel industries, they know the cyclone dust, SMS slurry, BP tailings. So from integrated steel plant, you are getting this type of waste, and also you are getting like LD slag, EF slag, and so on. So also you may get red mud from bauxite residue, or GGBS from steel plant, or ferrochrome slab from chromium. So look at this. What is the problem? If I go to soil, alumina, silica is 80-85% or 90%. Small percent of sodium, potassium, they are light metals. They are not hazardous. When it comes heavy metal, those are hazardous. We say we cannot intake more. That is why it is becoming hazardous. So you will see there are lots of difference. So the chemical formula is total, chemical composition is also different for different industrial waste. So they are not matching. Even coal mining which was saying waste rock. So most of the waste rock you will see, it is green I have said, it is almost satisfying what is there in our natural soil because it is topsoil only. So if you look at the crust of the earth, all the heavy metals are below. So that's why we are extracting it from below. So now you see, and what else? What is the, I will say, suppose say what is pH of soil? Acidic or basic? It is very around 7, 6.5, 7, 7.5 and so. So that's why it is not harmful. But look at this industrial where the pH varies from up to 12.5 also it can go. And bauxite residue also 11.5 or 12. pH is also high. What happens to pH? I will come later. And so also G value, you see. Some of the G, specific gravity, it can go very high. And also if you go to fly ash, it may also come very low. Specific gravity is very important. Even in the same material, if you take a bulk, in the same material it can have also different specific gravity. Because Dr. Ponda will say that when you are depositing, how it is deposited with different sizes. A slime, fine tailings or coarse tailing. This will also deposit. So their property is also different. So their specific gravity will be different. And what the important thing you see, as a civil engineer, if you go to a compaction curve and zero air void line, the specific gravity is most important. Even because to find out the void ratio, specific gravity is the most important factor. And that specific gravity, suppose it changes a little, your everything goes, the void ratio becomes different, so your all calculation goes wrong. So this way, people have tried to differentiate different like a fly ash, where it comes to in chemical composition, there are different high calcium fly ash, low calcium fly ash, people call it soft bituminous fly ash, lignite fly ash. So this way it has been divided. So I will not go to in that. Similarly, if you go to bauxite residue, you see iron content is very high compared to calcium or silica, other compound is less. Even 35 to 40% of the iron ore is there in red mud or the bauxite residue. So that's why specific grade is very high. So this way, if you go for, so this chemical composition varies from different. Even the bauxite residue, I have tried to also say there are two processes, they call this Bayer's process or sintered process. Mostly we follow the Bayer's process in Indian context. So that also makes a difference, because if the sintered process, the calcium content is more there, in Bayer's process, iron content is more there. So we have to see also that, we have to need to find it out. So what it tells, based on this one also, like when I am saying how this is making a difference, you are putting a slurry, and what you want, the slurry should immediately get settled down. As it settles down, so its own volt also it will be consolidated. But many a times what happens, you see the flocculation stage suppose continues for a long, then only it starts settling after getting a particular size, then these process itself get delayed, and what is consolidation? Self-weight only consolidation. So the consolidation process also becomes less. So why it is not getting settled? If you remember in our water resources, we are putting some coagulant. Why are putting coagulant for coagulant? Because that way the size will be more, then it will settle down. So why it is happening? So basic concept is that called zeta potential. So we need to calculate the zeta potential. That is based on the chemical, but that will tell you how quickly it will settle down. So this is what I said. This is pH value and zeta potential. If you have got 0, zeta potential 0 means no charge. If there is a charge, it will try to make a Brownian movement. So if it is no charge, it will settle down quickly. So that's why the chemical composition is important, and in that you also need to find out pH and this zeta potential. This is some of the experiment you will see I have done in the laboratory, how quickly this bauxite residue can settle down. Now though also people are trying to add some chemicals to it so that it gets settled down quickly. So this is how you see it gets changed, the sedimentation line change, so the consolidation then it will start. And what I want, this consolidation process should start as early as possible. You can decant the water and also the settlement process or consolidation process will start. This is another also thing which you can get it from this chemical composition called dispersive. This is from a red bud pond, suppose it is looking like a rock, and then as in water goes it is making a cut. So that is one property called dispersive. It doesn't have much strength. As the water goes in, it will just flow out. Even that negative DFS means some of it may get dissolved. And this if you see, you can also, if you are not able to visualize some of the things. Okay, so that picture I missed it. Even in the iron ore, still that mines, somewhere you will see there are some white patches are there. And white patches where this dispersion comes, and there may be a hole. Well, in the iron ore mines, not in the tailings. Another important property is mineralogy. This also we need to calculate, that is called X-ray diffraction. I am talking about the standard sand. Sand is quartz, quartz, quartz. And what our geotechnical engineering you have read, particle size more than 4.75 boulder, 4.75 to 75 micron is sand, less than 75 is silt and clay. It is nowhere written that what is a brick dust or a sawdust or anything. So we say the particle size. But that is not sufficient, because some people have tried to use this GG or anything. We crossed it to sand size. Will it behave like a sand? Or is it non-hazardous? So that is this only the grain size distribution is not sufficient. We need to know this mineralogy. So that we say all the particle size are of same, but different. I have taken ferrochrome slag. That is, I think, yes, ferrochrome slag divided magnetic and non-magnetic part, and this is red mud and this is sandstone. particle size are all same, it is sand size. So you see, they have got different minerals. Obviously, they will be different. Even in one fly ash from this lignite or high calcium fly ash, with a different fly ash fraction has different minerals. So what do you expect they will behave differently? So this is also, this is one, hopefully this font size becomes as less, but you will see this is iron ore tailing. Mostly there are 3 hematite, statistics I am giving average, standard deviation, maximum, minimum. If you see, first is hematite, there are 3-4 tailings there. One is your coarse tailing, fine tailing and slime. So if I take an example, suppose say overall hematite is 42.3%, but when it comes to, suppose a coarse tailing it is 35, and if I go to slime it is 45. So that means there is a difference of this one in terms of hematite, magnetite, goethite, iron, and specific gravity also varies with different fraction. So, and void ratio, Emax and minimum, and all these things get changed as I am going with different fraction. That is another challenge. And if you have seen, Dr. Panda was showing, as they are depositing, close to the dam it is coarse and away from it is slime. So all they have got different properties and how to analyze it. We are analyzing only factor safety. For factor safety we are going for a slip circle analysis. Okay. Then the shape. When I was talking about the shape, here I am talking about the genesis. Look at, because we have the knowledge of soil mechanics or geotechnical engineering and geology based on which we are trying to deal with tailings. Look at the right hand side, mostly it's mechanical process, sand, gravel, cross hote naturally that has been formed. But left hand side if you will go for, there are also different way you can come for, like thermogenesis. You might have lava that comes out, that becomes dry immediately, because that is the best pozlana what we call it as, and those are also spherical. Our fly ash, what it looks like, because same process, lava was high temperature comes out cooled quickly. Fly ash is also we are burning at high temperature and then coming out quickly. So that is also behaving. So that is called thermogenesis. So we have to see that how it has been generated accordingly. Can we correlate with the geotechnical properties? So the shape and other things may correlate with. And similarly, geosenses means, suppose think about the deep sea. So many plants and animals are dying out. That is also forming a soil. Calcareous soils they are forming it. When now we are going for around the close to seashore, we may have come across this, and there is a crossable, as you put the pile on it, may be crossed. So that now people are also getting somewhere, if that process is a microspheral, calcite precipitation and so on, they are doing it. So that is whatever it was there in the naturally, and now what we are getting from the industry, first we try to, it correlates to what type of naturally available material or the process. So this you see morphology, that is a fly ash, very spherical of different type. In fact, when I once curiosity I had burned that fly ash was like this, spherical and full. Then I put in acid and inside I found also what is there. I mean, this is not just for academic purpose, not for use. So that way you will see when the particles are spherical, what will happen? You know void ratio will have higher, because that will not fill in properly. What do we know? Angular sand is better. So that is the problem. So that's why fly ash, they call it a mineral admixture. Isliye cement, concrete, everywhere they are using because of these advantages. But for geotechnical engineering, does not have a strength. If it just becomes dry, it tries to fly. Then you put extra water, sprinkle water, all these things you have to do it. That we don't do in ordinary soil. So that is also called as a, this is one light, this spherical type, and also there, that's why I also call it it behaves like a dispersive soil. So this is, if you see other one. Here you see the first one is from bauxite residue, this is from the ferrochrome slag, and this is from GGBS. So all this, and this is from standard sand. So standard sand are that red mud sand, you will see there is no difference. Only the color, that's why I made it red, black. Just not to say that those are the black, red. So you see, they are all matching. But the chemistry is different, but the shape is same. So why it is important? It is important so you can do a particle chemistry and to know how much is well rounded, how much is rounded and so on. So an industry people cannot do it. In the academy somebody is sitting, so he has to make one analysis and finally say overall that waste consists of a what type of granular particles, rounded, sub-rounded, angular, subangular or flaky. So what type of it? So accordingly it will behave. Even whatever you see, rounded, accordingly the void ratio changes. So if the roundness is more, the void ratio is also more. You cannot help it. So this way, that is another aspect which we need to study when it is the first time we are going for industrial waste. So this is characterization. These are the different techniques. I am not. This is how we do it, or the student in academic institution can do it having time. So this way you can make it and then go for suppose a compaction. So you know the compaction property they are going for. Look at how it is changing for same fly ash, different origin. It can vary. If you will see, this is in 1 to 1.6 or even 1.8. It can vary depending upon the chemical properties or the specific gravity of this fly ash. So it can vary. I didn't show, and the particle size also vary widely in a wide range. In fact, okay, so it is not only fly ash. Also, I have shown it here for iron ore tailing, or in fact, there is also gold tailings. So the particle size also there is a wide variation. So something what we are going to use, we need also to analyze it. So these also variation of the particle size are we calculate, and some of it will also I didn't save it here, but even same plant. I was doing for a same plant Ponki near Kanpur. Previous student has done 2 years before or 1 year before. His result was not matching with my result. Now it is still more variation. Today we are getting Russian coal because where is come cheaper. Next day we will go to Australian coal. So they are all different. So that way, that is also another challenge. Then you see, look at the compaction properties. Different I am talking about. Zinc, coal ash, soil, fly ash, red mud, whatever you see, copper slag. The specific, that if you see the compaction 1.3 up to 2.23, 13 to 23 in kilometer meter cube, it varies. This also varies, so that also you have to keep in mind in such cases how this can make a difference. And one more, whether I will use the same sample for 5 tests for a compaction or different samples. If you take the same samples, where compacting also sometimes some of the samples get crossed. Your particle size and distribution will change. So when you are compacting the site with the roller, some of it also get compacted and you get a different what you are designed, also not the same. So that also gets changed, we need to do it. Okay, so this is other properties like all the gradation shift, as I am taking for different size particles, how it is crossed, particularly coarse grain. And this also happen in iron ore tailing. That I had gone with another that is called coal mine OB. This is also, you see, before test, and suppose I am taking one example. How much was the final? So 70%, suppose I am going 1 millimeter size, it was around 80% finer. Now it will go for same 80% finer, the particle is less, or one time I go it, now 95% become finer. So that means particle is getting crossed. So because in the site you have to compact with the roller. So that is also getting crossed. So that you need to also identify in the laboratory whether it is getting crossed with compaction or not. So this is another, because we call it CU or CC, grain size distribution. If you see, so they are all changing depending upon the particle size. And if you say different, this is one only, this is I think only iron ore tailing. So this optimum moisture content, all these things are changing, and the value is average is 11.8, maximum 14, and this is 10. Why this value is less or more, optimum content will depend upon, that is one aspect. This also I want to make it clear, higher granular size, the optimum content should be less. But there are also, we found some of the industrial waste like the bauxite residue, they are having some internal pores. So it will absorb more water than required. So that aspect is not there in natural sand. Natural sand cannot absorb more than what is required for the workability, but the industrial waste can also suck some of the water in its void space. So I thank you here, and also I acknowledge the supports from different industry and ministry for conducting this test. So I will be happy if you have got some queries. Yes.
पीछे से शुरू.
Sir, only one question.
Yes, please.
Sir,
I know I didn't want to stand in front of you for long.
one question only.
Yes.
Sir, in one of your slide, you had written that we have to bring the pH value of red mud between 7 to 7.5 to get the sedimentation in your initial.
Yes, that zeta potential to bring it to bring it, that is called zeta potential.
But sir, generally for red mud we get the pH value higher than 11, 12.
Yes, that's what I said.
So how to bring that to?
Yes, that is what I have done. It will see. In this case, we have added some chemicals.
Okay.
Applying those chemicals only, we could bring it, because people have tried even using phosphoric acid.
Okay.
And here we try to use some biopolymers.
Right, sir.
So then only it will come. Even people have used sodium chloride.
But sir, for large area of tailing dam,
Exactly.
how much area we will be able to get pH value 7 to 7. For entire area, can we do that? Like
Yes,
for
that is
entire
the
area,
then that is why I didn't show you one case. Now that is the technology called technology readiness level. TRL. I didn't show the diagram here, I forgot it. So now TRL level required from 1 to 9. 9 is the final model, business model called. This is altogether up to only academic interest. Now we need to do some pilot study. In another project I will say we did some pilot study also, because many times what happens, we did in the laboratory. We need to see there how much effective it is.
how much effective and how much area it covers, sir? Because tailing dams are very large, sir.
No.
Especially for aluminium.
No, that is not there at that time. What we are saying, that when you are dumping,
Yeah.
that time with the throw with the pipe, slurry, you are mixing the slurry and throw it.
Okay. During
That was
dumping itself?
Yes.
Okay.
That was the idea. Even I visited some, even if you see, there are similarity between BP tailings and redwood. BP tailings also pH very high. Those who are from steel industry, they can tell it is also more than 11.5. And both looks exactly similar.
What is BP tailing, sir?
Beneficiation plant tailing.
Verification.
Yeah, beneficiation plant tailing in steel industries.
Okay. I know.
JSW people can tell it.
Okay.
So that also exactly looks red,
Right, sir.
like what is bauxite residue comes or red mud comes.
Right, sir.
pH is also similar,
12. Okay.
11.5, 12 and so on.
Right.
And also it does not settle immediately, and another problem you will see, it does not also consolidate quickly. And one, in fact, what happens now, suppose say we will go for dry stacking, or suppose say water. I have seen one case, what happens, you now dump it, next you make a cut. Every 1 or 2 meters will say there is a thin layer of white color in red water. What happens, the water try to segregate, I mean suppose I am putting one layer, then I start dumping. So the top where the roller goes, that becomes hard, somewhat impermeable. Then what, as you go again dumping, the seepage water, or what you will say, they even say 20% or 40% water what is present in the dry stacking also, that settles on the top of it. And that is nothing but a sodium hydroxide and so on, it gets white color. So these parts, like this pH which is increasing, so now I need to, if I want to get it settled, so I need to make this pH to this level so that it becomes with zero potential, and then only it will settle down. So this is only possible while dumping. Then after it is difficult.
Yeah, then after mixing that is very difficult.
Very difficult. And also once it comes to settle down, what is the use of this one?
Yeah.
So there is no point. Like in the during now this monsoon is coming, what the people will do? We have got muddy water, put some alum and take it becomes clean.
Yeah.
That is like this. So that is what we are putting alum. Immediately water becomes clean. So similar type.
So sir, you are saying that if we bring pH between 7 to 7.5, settlement
will be quicker. Yes.
It helps in settling the red mud itself.
And simple example, that's why I said morning water. You simply wait till morning also it may get settled down. But how quickly you can take it?
Yeah.
Still you feel that something is there.
Correct.
And also in fact in layer I will say this particular red mud, the bottom first will go settle down, which is coarse grain somewhat more in iron, and then after top will look like a after settlement. I don't have that diagram even, or it may be. Okay, it's coming other way. So this one, so this will be something like blackish, and then slowly it will be reddish. Yes, please.
Sir, I have a question. Whatever you are telling about the neutralization of this red mud, definitely the heavier particles are the iron particles which will be settling down first. But after settling of this and getting neutralized, is there any uses of this? Because still it is difficult for the users or anything.
Users of what? Because you see, sometimes actually I might have I sent contact with presentation there. Like pH, that water from one red mud pond, I will not tell about any company name here. So I found that it is almost red water. So I took that water to check how much equivalent sodium hydroxide. Because what they do, they also recycle it. Because they are getting that high pH and again utilizing for their process. That is also helping. But the idea here it is that it is different when you don't want to bring that back. Or away from it if you want to use it. But the problem there I found is what the water I collected, the sodium equivalent is very less. Maybe the pH is 11 fine, but what I need also the equivalent sodium hydroxide, which I want to put it in their soil so that I bleach it. But that equivalent is very less.
It is less than 1 GPa.
Yes. That also I have read at this, I think, I don't have photograph, I collected, I checked very less. Also what I want, my idea was different. Suppose a sodium hydroxide is there, sodium hydroxide is also a good activator. If I add it with the fly ash, it can also should give a strength. If I have sufficient, because the sodium hydroxide will go for chemical formula, it is around 11%. But that water itself does not have that equivalent.
Yes.
That is the problem. Okay?
Sir, the red mud is considered as a hazardous material. How it can be neutralized, sir?
You see, why hazardous? Even one time, that's why I said 30 years before fly ash, a very interesting thing happened. Before this joining here, I was at NIT Raurkela. I was also looking after different constructions. I wanted to introduce in 2011 fly ash rigs. 2011, not before, 14 years before only. There was a uproar. Coal contains radioactive. तो ये fly ash में होगा, all faculty member try to put this as a problem. And then I said, how much is the radioactive material in coal? उसके बाद then I'm burning it. 40% is that ash. Because out of the 40% is ash, suppose Indian coal I am talking about. Then in that 40%, how much is there? Then now that time I could approve it. Then another problem was fly ash lime gypsum brick. It was breakable, immediately break it. So then I had to do in the laboratory, I added 8 to 9% and manufacture, they told the contractor you have to build it here and manufacture it itself. So every day you are manufacturing of 8,000, 24,000 brick. Then in all that 450 crore, they only use fly ash brick. So once upon a time, why I am saying fly ash was also considered as a hazardous. Why they were not allowed to dump it in the open ground? Now only 2016 ke baad, now only they are saying you can dump it, mine filling everywhere putting it. But that was not there. Because then I tried to interact with one Russian scientist working on the similar field. Their coal has a problem. They have got radioactive material. He said me, are you not facing this difficulty? I said, we don't have, no report is there. So the problem is when we are talking about hazardous, hazardous has a different meaning. So that we need to, why we are calling it as hazardous?
Because it has more pH value.
Okay. pH, if you will see, now suppose I am civil engineer. When the steel will start corrosion?
Contact with air and water.
That means pH reduces. Unless pH comes to 10, the steel will not corrode. That's why I am putting cement concrete. pH is 12.5, 13. That's why steel will not corrode if the pH value does not come to 10.5. इसलिए पुराना structure होने के बाद, so that also now outside when I am checking it, I just check that in terms of electric voltage. So when we are talking about pH hazardous, that is hazardous to what metal? Or hazardous to, I think one hazardous you can say, when pH is there, there will be no, that is what experiment I did once. When I tried to use red mud in 2009 or 10 to just characterize, I had an idea that earthworm, you know, earthworms, they convert the soil. I said, people are not using, let's put some earthworms. Earthworms will convert it naturally. All they died within 1 week. Problem, they cannot survive in high pH. So similarly, no grass will grow on high pH. So when you are talking about hazardous, you have to see where it is the problem. So that's why we put some pH resistant bacteria, those who can work. Because even if the pH is 12 also, still they can survive. So that is the problem. This is hazardous to what? Hazardous to, sometimes high pH is hazardous to some metals, hazardous to these plants, hazardous to this bacteria or other human bodies. So that's why it is hazardous. So if I can now reduce pH, is it sufficient? Suppose now I reduce to 7. Is it hazardous free? No. Because then what are the heavy metals it contains? You see, we take copper, zinc, chromium, every day in different forms we are taking it. Then why it is hazardous? When the dose becomes more than sufficient. So they calculate how much daily intake you are taking. Why we say the labor which exposure to the industry is more prone. How much daily you are taking, how many days you are exposed to, multiplied by how many days you are serving or working on that. That only calculates the dose. If it is so, then it becomes hazardous. So these hazardous has different meaning. Right now, so we are just trying to, that's what I said, fly ash also once upon they were not allowed to dump anywhere. But now when they found no harm, they are now saying put it in the low-lying area, put it in the mines, put it in anywhere. Still we are doubt whether what we are doing is correct or in long term it may affect. Still we have a doubt. But for the time being it has been allowed. Similarly, when you are talking about hazardous, now the idea is to calculate what are the things which may be hazardous, which is lying there, can we extract it, or how much hazardous, what should be the dose, and where we can use it. So that's why I said at the very beginning, if you will say what is resource, byproduct, wealth, byproduct and the waste. So we have got, still knowledge is limited. We are trying to do it. Yes, please.
Do you have more questions?
Any questions? Okay. So anyway, so if in 2-3 days again you have got, so that's why I will say only, we are still learning. And all this, whatever I have seen, because I have seen this in 30-35 years, things get changed. That's why I put that always in the presentation. is getting, because when I started fly, the percentage utilization was only 5%. 5% fly ash are being used. Now what is the percentage of use of fly ash? More than 95%. Only thing, the number of thermal plant has increased, for which only still that is also 18 million, still is being unutilized. So that way, so that we are trying to get information about that, what we calling that a waste not able to get information about it, or we are calling it as hazardous or non-hazardous and so on. So the day will come, if we can identify something or do some treatment by making, now chromium. Suppose when what the people were thinking about chromium, which chromium is, anybody, I think nobody from chromium industry, hexavalent or trivalent, there were two groups. People are not knowing which is hazardous. So that's what, only after I identified, somebody said that this is a problem. But by default, what I will say, chromium is bad. So that knowledge is required. Mosquito, how many female anopheles or any mosquito is dangerous. So that is called knowledge. Unless we get this information, till that point, we say it's not good. Okay, so other properties again, Dr. Panda, and I will also continue. I will mostly continue on this laboratory, other things, and some standards also will continue. And tomorrow flow, yes, please, around 6. So we'll again, okay, you can announce better. So please come.